Welcome to EDU World Space.
In problem 36, we have that a lensmaker wants to make a magnifying glass with an object that has a lens that has an index of refraction of 1.55, and the radius of curvature, R1 and R2, are to have the same magnitude. So let's go ahead and just call the magnitude of R1 and R2 R. And to solve this, we'll use the lensmaker's equation, which is equation 19. And we have 1 over the focal length is equal to the index of refraction minus 1. And that is multiplied through 1 over R1 minus 1 over R2. And so all the magnifying glasses I have seen are converging. So if we have like a converging lens that looks something like this, then where this is, let's call this R1, and let's call this one R2. By the sign convention determined in our textbook, this radius of curvature, R1, is positive, and the radius of curvature for R2 is negative. Okay, so using this idea, then we will have 1 over f, and the focal length of a converging lens is positive, is equal to n minus 1 over R1, and R1 would now be positive R, minus 1 over R2, where R2 is negative R. Okay, so now our equation becomes n minus 1 multiplied by 2 over R. So that's 1 over f. All right. And I believe I left out an important detail in this question. We're also given the focal length, which is equal to 20 centimeters. Yeah, apologize, but I forgot to put that in. Okay, so now we have the focal length, we have the index of refraction. It's just a matter of doing a little bit of rearranging so that we can solve for R. So we can readily do this if we multiply the side here, multiply this side by f, the left and right sides both by f, and then multiply both sides also by r. And if I do that, and then I have r on this side is equal to n minus 1 times 2f. And if I just substitute the numbers that I have, so then I have 1.55 minus 1 times 2 times 20 centimeters, which gives me 22 centimeters. And so this is the radius of curvature, or the magnitude of the radius of curvature for both of these R1 and R2.